Hi everyone, welcome back to my videos. So I like to solve two competition geometry problems in this video, and I'm going to follow up with another video with two slightly more difficult problems. So we're given the area of two squares are marked. So the square on the left has area 9, the square on the right has area 4. Find the area of the middle square. So what we can do is we can mark off these angles 1, 2, 3, 4. Measure of angle 1 plus measure of angle ACD plus measure of angle 3 equals 180 degrees. Measure of angle ACD equals 90 degrees because this middle object's square, so it has 4 right angles. So measure of angle 1 plus measure of angle 3 equals 90 degrees. So angle 1 is complementary to angle 3. Since ABCD is a right triangle, angle 1 is complementary to angle 2, and the same goes for this right triangle CED. Angle 3 is complementary to angle 4. So if we look at this relation, these relations down here, angle 1 is complementary to angle 3, and angle 1 is complementary to angle 2. So angle 2 is congruent to angle 3 because angles that are complementary to the same angle are congruent. Angle 1 is complementary to angle 3, and angle 3 is complementary to angle 4. So angle 1 is congruent to angle 4 because angles that are complementary to the same angle are congruent. So we can write that down. We know that this middle thing is a square, so its sides are all congruent. So side AC is congruent to side CD. So we can use the angle side angle postulate to get triangle CAB is congruent to triangle DCE. So by corresponding parts, congruent triangles are congruent. AB is congruent to CE, and CB is congruent to DE. Well, AB measures 3, right? Because the area of this left square is 9, and the area of this right square is 4, so DE equals 2. So we can plug in these values, and if we look at this side AC, so we can use the Pythagorean theorem, AB squared plus BC squared equals AC squared. So we get AC squared equals 3 squared plus 2 squared. So 9 plus 4 equals 13, and therefore AC equals square root of 13. So the area of the square is going to be square root of 13 squared, which is 13. Now let's look at problem 2. Square EFGH has area 20 centimeters squared, and we have a circle shown. Find the area of rectangle ABCD. So one way we can do this is we can kind of create this coordinate system where the x-axis lies on the diameter AB, and then we can construct the y-axis such that the y-axis is perpendicular and bisects chord EF. So we know from geometry that if a line bisects a chord and is perpendicular to that chord, then that line will pass through the center of the circle. So we know that the x and y axis will intersect at the center of this circle. So we know that square EFGH has area 20 centimeters squared, so each side is going to have what, 20 square root of 20 centimeters length. So if we want to find the radius of the circle, say OF, well, we know that F is going to have x coordinate square root of 20 divided by 2, and y coordinate square root of 20, right? Because this is in the middle of this GH, so this is, we have to take half the length of a side to get this value square root of 20 divided by 2. So we can use the Pythagorean theorem, or whatever you want to call it, to get radius OF has length 5 centimeters. So we know that from the figure OF equals OB, which is equal to OC, Z, sorry. So diameter AB is going to be 2 times the length of this radius, right? OF equals OB, which is equal to 5. So length of AB equals 2 times 5 centimeters equals 10 centimeters. So we already know that the length of AB here is 10 centimeters. All we have to do is find the length of the other side, say AC, to get the area of this rectangle. So we know that OZ equals AC equals BD, right? And OZ is what? Well, it's just the radius of the circle. So it measures 5 centimeters. So the area of rectangle ABCD is equal to 5 times 10 centimeters squared, which is 50 centimeters squared. So these are interesting problems to solve, and I actually made more slides, but I'm gonna split this. I'm gonna split what I did into 2 videos. So this is the first half. So I hope you enjoyed watching this video, and I hope to see you during my next tutorials. All right, take care, guys. Bye.